Okay, here we have a rail car of mass 20,000 kilograms moving at 5 meters per second towards another rail car that is twice as massive at 40,000 kilograms, but it's also in motion in the same direction but slower at 1.8 meters per second. So this is before they collide. We're doing a collision or explosion, so we know we have to use momentum, and we know that momentum before, when we add it all up, has to equal momentum after. We just have to watch our signs. So before, we have two objects moving. We've got the 20,000 kilogram rail car moving at 5 meters per second, and we're just going to assign it to the right. And we've got the 40,000 kilogram rail car moving more slowly at 1.8 meters per second. So it stands to reason that this one at the back is going to catch the one at the front, and there's going to be a collision. And when it collides, there's going to be maybe a little bit of energy loss as they smash together. But now we got to read carefully. After the collision, the lighter car, the first car, actually rebounds. It starts to move backwards at 1.5 meters per second. So be careful when you label the velocity. The velocity of this car is slower now, but it's in the other direction. And I'm going to call this V1 prime. That's my final velocity of object 1, and it's to the left. So I've depicted my arrow pointed to the left, 1.5 meters per second. We're trying to figure out, as a result of that collision, what is the velocity of the second rail car after the collision. So we know our basic formula. We know that momentum before has to add up to momentum after. Now, how many objects have momentum before? Well, I've got the green rail car with a velocity to the right. It's moving, so it has momentum. And the yellow rail car, which also has a velocity to the right, it's also moving. So they both have momentum and they're both positive. So I should have two terms on the left. P1 plus, and I'll keep it color-coded just so we can keep track, plus P2. Two momenta on the left. Now, after they collide, P1 is still moving, so I still have a final momentum for P1. And P2 is still moving, so I still have a final momentum for P2. So I still have two terms on the right-hand side. Now, momentum is just mv. Mass has to be in kilograms. Velocity has to be in meters per second. I check all my units. They're all good to go. So now it's just a matter of plugging in my equations. So when I do this, and I'm just going to do it all in yellow now so we can see how this goes. I need mass 1 v1 initial, but that's a vector, so we got to watch the sign, plus mass 2 v2, my initial velocity for v2, watch the sign, equals mass 1 v1 prime, or v1 final, plus mass 2 v2 prime. Putting in our values, I get 20,000 kilograms for mass 1. Its initial velocity is to the right, so I'm going to say it's positive 5 meters per second. Plus 40,000 kilograms. And it's also moving to the right, so its velocity is also positive initially at 1.8 meters per second, as long as I'm consistent with the signs. After the collision, mass 1, still 20,000 kilograms, but now its velocity is to the left, so I've got to make sure that I put in a negative value in there. I'm going to do that in blue to highlight it. Its final velocity is actually negative 1.5 meters per second. So that's the key to this whole question. You've got to make sure you get your signs right. And then we've got to figure out how fast the 40,000 kilogram object is moving. We're looking for V2 prime. And I just ran out of room, but we're looking for this last variable on the right. So you do all your math, you add together everything on the left, and I get 20,000 times 5 plus 40,000 times 1.8 gives me on the left 172,000 kilogram meters per second is my overall momentum before. And on the right-hand side, I get 20,000 times 1.5, which is 30,000. But remember, we're timesing it by negative 1.5, so that's negative 30,000. So the momentum of that first car after the collision is negative 30,000 kilogram meters per second, plus 40,000 times V2 prime. So we add a 30,000 to both sides, divide by 40,000, and you end up getting V2 prime, a positive answer, so it tells you it's still moving to the right, of 5.0 meters per second. So same direction, still moving to the right.